O'Reilly!
It's Superstart Battery Month at O'Reilly Auto Parts. Get up to a $25 gift card after rebate with the purchase of select Superstart batteries. Our professional parts people will test your old battery for free and recommend the right battery for your vehicle. For power, performance, and reliability, choose Superstart batteries only at O'Reilly Auto Parts.
O'Reilly Auto Parts.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2. 1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
Hello once again, and thank you for joining us on episode 187 of the Space Nuts podcast. My name's Andrew Dunkley, and with me as always is Professor Fred Watson, astronomer at large. Hello, Fred.
Hey, Andrew, how are you doing? Happy 187th episode.
And to you too. It's a milestone for reasons I could not possibly glean.
No, well, it's probably the sum of our ages or something like that.
I was just going to say it's one more episode than we added up last week.
Yeah, maybe so.
That's the significance of it. But I tell you what, we have got a couple of stories today that will make eyebrows pierce hairlines, if you can reach that far.
It can't in my case.
I was going to say, notwithstanding my current partner in crime here, we're going to look at an asteroid that's been found inside the orbit of Venus. This has happened this year. In the last couple of weeks, this discovery's been made. So it's pretty astounding. You don't think about asteroids being sort of within that orbit range, but there it is. There's also another thing that sort of goes a lot further than we thought, and that's Earth's atmosphere. In fact, it seems the moon passes through the Earth's atmosphere.
Indeed.
Huh? What? Hello?
I didn't know that.
Yeah, we can walk there. So we'll investigate that. And surprisingly, Fred, people have got questions about black holes.
Well, what a coincidence.
That surprises me. So we're going to knock off a couple of those because, to be honest, if we stopped answering questions about black holes, we probably wouldn't have any questions to answer. But we're going to look at two completely something similar questions, but very different angles, I suppose you could say. But someone's got an interesting thought on black hole collisions, and we'll get to that in a little while. But first of all, Fred, let's talk about this asteroid that's been found closer to the sun than Venus, which sounds, that sounds normal for some of the time, but this is all of the time from what I'm understanding.
Indeed, that's absolutely right. And it is a bit surprising. When I was a lad, 187 years ago, the asteroids all stayed. They were terribly well behaved. They all stayed between the orbits of Mars and Jupiter. We knew of really very few that strayed outside that range. But of course, as time has gone on, we've discovered more and more and more asteroids. And there is now a class of asteroids which are called Artiras. And I think they're named after the sort of prototype of the class, which is probably called Artira. And Artiras are asteroids whose orbits are wholly within the orbit of the Earth. So it's not a very common place to be, an asteroid that's, we know of many asteroids whose orbits cross the orbit of Earth, but Artiras have orbits that are entirely inside the orbit of Earth, so they always are nearer to the sun than the Earth is. But there's only 21 of them. They're not numerous objects, and so it's perhaps surprising that we found an even more extreme example of these, and it was found, as you said, this year. In fact, the observations were made on the 4th of January, 2020, at a place that, in its own strange way, is close to my heart, because it's the what used to be called the Palomar-Schmidt telescope. It's now it's basically now called the ZTF, which is the Zwicky Transients Factory.
And for all you Americans, it's the ZTF.
I'm sorry. I'm so sorry for that. It's, of
You've got to
course,
speak the universal language here, Fred.
we have indeed. Yes, that's right. So a few subtleties about this. Well, the telescope itself, the reason why I'm very fond of it is that it is the twin, effectively, of the United Kingdom Schmidt telescope, which is at Siding Spring Observatory, and which is actually what brought me to live in Australia in the first place 100 years ago. The Caltech machine, though, the ZTF, named after Fritz Zwicky, of course, the great astronomer in the 1920s and 30s, actually the discoverer of dark matter, but that's another story. The telescope is a 1.2 meter or 48-inch Schmidt telescope, and it was the basis of that Palomar Schmidt, or sometimes called the Ocean Schmidt now because it was renamed a few years ago, and is now the Zwicky Transient Facility. Our Schmidt telescope was essentially modelled on that one, also with a 1.2 meter diameter corrector. So these telescopes are wide-angle telescopes. They were built for photography. Our telescope now does something quite different. It will soon when the commissioning work is finished on our new Starbugs instrument. It uses fibre optics to look at many objects at a time, whereas the Caltech one at Mount Palomar actually has a wide-angle electronic camera, and that is really why it can be used for looking for objects that change in space. And by change, I mean they either get brighter or dimmer, or they move. And of course, this thing moves. That's how you find asteroids. You look at them 1 minute and look at them a few minutes or a few hours later, and they've moved in space, and that tells you that it's a relatively nearby object. Now, that discovery, though, is unusual because if you think about the orbit of an object that lies within the Earth's orbit, you're only going to see it soon after sunset or shortly before sunrise, because the object's always going to be close to the sun in the sky. And that is even more extreme in this case, because the object, which I'll tell you its name, 2020 AV2, it actually, as you said right at the beginning, it keeps its orbit entirely within the orbit of Venus, not just inside the Earth's orbit, but inside the orbit of Venus. And of course, because it's inside the Earth's orbit, it means it's an Artera asteroid. As I mentioned, they're ones whose orbits are always within the Earth's. But people are now calling this a Vatera because it's within the orbit of Venus, and it is the first one that has been discovered.
Well, how dare we just assume that everything associates with Earth? I mean,
exactly.
The Venusians must be getting pretty steamed.
Yeah, they must be. And actually...
Well, they are actually getting quite steamed.
Well, they steam me all the time. That's right. It's a horrible place. The sulfuric acid drizzle and all the rest of it. It makes you wonder, though, whether we'll find ones inside the orbit of Mercury, which might be called Matera or asteroids. Anyway, 2020 AV2, the first Venus or internal to Venus asteroid, is only no more than 3 kilometers across. Its orbit is quite elongated, and in fact, when it's at its closest to the sun, it's not far from the orbit of Mercury. So you can bet your life we'll find asteroids eventually which are within the orbit of Mercury. So how did it get there? Well, one of the professors of physics at California Institute of Technology, who's actually one of the co-discoverers of this object, or he's a co-investigator on the Zwicky Transient Factory. He says in his press release, an encounter with a planet probably flung the asteroid into Venus's orbit. It's the opposite of what happens when a space mission swings by a planet for a gravity boost. Instead of gaining energy from a planet, it loses it. And there is another comment as well.
So more or less gets stuck. It was on its way somewhere and got distracted by
that's right.
a pretty girl, and that was that.
More likely the gravitational pull of maybe Mars, maybe Jupiter. It depends on where it started its journey.
So it's got a big D cell.
Yeah. The only pretty girl in the solar system is Venus, which is the only female planet. So
like what I said.
Yeah, that's right. So it could have been Venus as well. Another of the colleagues of Tom Prince at Caltech, George Hello, Helou, I think is how you pronounce it, Helou.
Hell yeah.
Not, it could be hell yeah, not hello. He said, getting past the orbit of Venus must have been challenging. The only way it will ever get out of its orbit is if it gets flung out via a gravitational encounter with Mercury or Venus. But more likely, it will end up crashing on one of those two planets. That's a really interesting prognosis for this little world that, until the beginning of this year, we didn't know about.
I suppose we shouldn't be too surprised because there are things coming and going all the time, and there are a lot of various forces acting upon and against each other from time to time. It stands to reason that, you're not going to just find asteroids in the outer reaches. Here we are with 21 of them that are just sort of flinging themselves around inside Earth's orbit going, oh, this is nice. I could stay here. Or whatever they want to do, really. But it's all subject to the forces of gravity.
Exactly. What I think is the really interesting aspect of this is that people will, of course, encouraged by this discovery, look for more, because we don't know whether there are more of these internal to Venus orbit asteroids, or whether 2020 AV2 is unique. But notwithstanding the Zwicky Transient Factory, the ZTF, there is a new facility which will come online. I think it actually is later this year. It's been in construction for a good while, maybe 10 years or so. I saw it last year on top of its mountain in northern Chile. It's until very recently, it was called the LSST, which is the Large Synoptic Survey Telescope. This is an 8-meter class telescope, which will survey the entire southern sky every week, effectively, every 6 nights.
Wow. That's impressive.
That's right. And that will be turning up objects, small objects in the solar system like you've never heard before.
So chances are, you're going to love this, Fred, chances are we're going to find a Moa.
I do like that, yes. A Moa, or maybe even Oumuamua. Talking of naming weird names, I'm glad you mentioned that, because it lets me segue to something I meant to say actually when we were recording last week, that what was being called the Large Synoptic Survey Telescope has been renamed. It has a formal name, which I'm absolutely delighted with, because it commemorates one of the greatest women in astronomy, Vera Rubin. So it will be called the Vera Rubin Observatory when it comes online, and that's a great name.
It is.
Vera, of course, also the person who put dark matter on the map back in the 1970s.
Indeed, and it's a good thing that changing the names of telescopes doesn't bring the same bad luck as changing the names of ships. So all is well.
That's
apparently
correct.
It's bad luck to rename a boat or a ship. I don't know why, but I'm told that's the case. Whether or not anything ever happens, I don't know. Well, in the Bark Endeavour, which is one of the great ships in our history, used to be called something completely different. It was a coal scuttle or something. So,
yeah. Well, let me. That's an interesting footnote to that, is that certainly the two telescopes for which I've been responsible here in Australia, the Anglo-Australian Telescope and the United Kingdom Schmidt Telescope, even though the institutions that run them have gone through several changes, the names have been sacrosanct. They were built as those things, and that's how they've stayed. So it's nothing to do with bad luck. It's just more that it's convenient to keep the same names, because otherwise you get mixed up with things like the Ocean Schmidt and the Zwicky Transient Factory.
I thought one of the greatest name changes ever was Anglo-Australian Observatory to Australian Astronomical Observatory, because they didn't have to change the logo.
Well, it's even better than that, because that the Sydney end of that institution is now Australian Astronomical Optics, and they've still got the same logo. We put it together in 1991, and it's
that is just beautiful.
Yeah,
I love it.
Stuff. We know how to save money, Andrew.
Yes, indeed.
No mucking around designing new logos. If you've got a good one, you stick with it, even if the name of the place changes.
Oh dear, it's brilliant. All right, so now we know they're there. We're going to go look for more of these asteroids that are orbiting within Earth's orbit, and Venus's for that matter, and probably Mercury's as well. But yes, 21 so far. There may be more. You're listening to Space Nuts. Andrew Dunkley here with, of course, Fred Watson.
Okay, we checked all 4 systems and keying with a go.
Space Nuts.
Now, if you would like to become a patron of the Space Nuts podcast, it's easy. Just write a check for $1 million and send it to this address. Or you could go to patreon.com/spacenuts and spend $999,997 less. And be a patron and supporter of the Space Nuts podcast. The advantages being you get a commercial-free version of the Space Nuts podcast. You get it early, and you get bonus material. So pop along to patreon.com/spacenuts. Check it out. If it's not for you, that's fine. But if you would like to sign up, there are all sorts of levels of membership. It's self-explanatory, but you might want to have a look and join us as a patron and support our podcast. We'd be thrilled if you did. Now, Fred, we are going to look at something that is a bit of a surprise. We've talked about Earth's atmosphere and how to get out of the atmosphere, you've got to travel 80 to 100 kilometres, and then voila, no more atmosphere. Apparently, that's not true. In fact, you have to go hundreds of thousands of miles to get beyond our atmosphere, and the moon actually goes through our atmosphere. I'm a little bit confused. What's happening here?
It's a very, very thin component of the Earth's atmosphere. So as the lead author of the study that we're reporting here, whose name is Igor Balyukin, and he's at the Russia Space Research Institute, as he says, on Earth, we would call it a vacuum. So it is still, there is something there, but and it is part of the envelope of gas within which the Earth orbits the Sun. It's actually, just to give it a slightly, different tone from the word atmosphere, which suggests something quite thick and quite dense. This is called a geocorona. The geocorona is a very tenuous cloud of hydrogen atoms. And as you said, it extends hundreds of thousands of miles away, 390,000 miles or 630,000 kilometers. And just to give you, give you the fix on it, the moon's orbital distance on average is 239,000 miles or 384,000 kilometers. So it's well within that. This almost extends kind of twice as far as the moon's orbit is. But it's not a thick atmosphere, certainly nothing you could breathe. It is hydrogen atoms. We've kind of known about it for a long time because images taken from the moon show back in the era of Apollo, 1972, saw the Apollo 16 astronauts take images of the Earth in ultraviolet light, and you need that to show up the hydrogen because it radiates basically ultraviolet when it's excited. But there are images of the Earth showing this extended glow around it, much, much more extended than the atmosphere itself. So people knew about it then, but it's only by a reanalysis, actually, done by the Russian group of data from SOHO, which I think is still going. SOHO is the Solar and Heliospheric Observatory. It was launched back in 1995. The end of 1995, about 24 years ago. 24 years ago. It has an instrument on board called the Solar Wind Anisotropies Instrument, or SWAN, which is quite a nice name. Anisotropy is different in different directions. So if something's isotropic, it's the same in all directions. If it's anisotropic, it's not.
Right.
So it's looking basically at that. And the SWAN instrument basically measured that light, ultraviolet light, given by glowing hydrogen, and found that that you can map the geocorona. You can map this cloud of hydrogen around the Earth, and you can see that it is denser on the day side of the Earth, and that's because you're feeling the solar radiation on that side, so it kind of compresses the geocorona. By dense, though, they mean 70 hydrogen atoms per cubic centimetre, which is kind of not much.
No, really, when you're talking about the size of those things.
Yeah, that's why the lead author says on Earth we would call it a vacuum. On the other side, it's less than that. It's 1 atom per 5 cubic centimetres, and that's at the distance of the Moon on the far side. Okay. Anyway, it's really interesting stuff that we now have essentially a map of this curious elongated envelope of gas. It's elongated in the direction away from the Sun. Because of that radiation pressure I was just mentioning. And it comes from mapping data by a 24-year-old spacecraft that I believe is still doing its thing.
Yeah, I mean, SOHO was primarily aimed at looking at the Sun, wasn't it? That was its primary function. Exactly,
that's right, which is why it's the Solar and Heliospheric Observatory. But the heliosphere, that's the the component of the Sun's atmosphere that extends effectively out to where we are on Earth by the solar wind. So that's very much part of its remit. And the spacecraft has basically looked back towards the Earth. It's, if I remember rightly, it's in orbit around L1. That's the first Lagrange point, which is the balance point between the Earth and the Sun, where the gravitational pull balances out. So it spends a lot of its time looking at the Sun, but it can also look back at the Earth. And that's how these new observations have been made.
So, by way of comparison, we now know that the Earth's atmosphere, or, a variation of it, spreads out that sort of distance. What about other planets?
Very likely.
Yeah.
It's almost certainly the case. Well, we know that I often in one of my talks show images of Mars, rather similar to the ones that the Apollo astronauts took of the Earth, showing this extended corona of hydrogen. On Mars, you can see the same sort of thing, because, of course, we can look at Mars with very sensitive instruments from Earth and from spacecraft. That's actually telling you that components of Mars's atmosphere, carbon is one of them, I think, hydrogen also, they're leaking away into space. And it's actually because Mars is too small to hang on to them, which is why there's no future in trying to terraform Mars, because it's not big enough to hold on to an Earth-like atmosphere at those temperatures. So, yes, that's certainly true. And I would guess, although I don't have anything that I can pull out of my memory banks, that Venus is the same.
I was going to say, does it vary according to the kind of atmosphere? Because Venus's atmosphere is probably, much, much more active than most in terms of a rocky planet. Yeah,
very dense atmosphere, carbon dioxide.
Yeah, pretty good place to go and camp with your marshmallows. But
marshmallows, you mean?
Marshmallows.
Yeah.
Yeah. All right. So, yes, the atmosphere goes far and beyond what we ever anticipated, but it's pretty much useless. That's what we're saying, isn't it?
Although knowing about it is important, it may well, it's part of space exploration, I guess, is knowing about what the environment of a planet like Earth is. And there is a postscript to this, which I meant to mention, and that is when we're looking at when we are looking at other worlds, and I'm now talking about not just planets, but moons of planets, and this has been the case certainly with some of the moons of Saturn and Jupiter. If you find a hydrogen envelope, you usually associate it with water at or near the surface. And indeed, that's been the case. We now know of, several worlds that have got this structure with a rocky core, a water envelope around it, and then around that an envelope of ice, like Enceladus, like Titan, like Europa. And they too they have these plumes of hydrogen, which is one of the things that is taken as an indicator of liquid of water, maybe even frozen water, but water down on the surface.
Fascinating. All right. You're listening to the Space Nuts podcast, episode 187, with Professor Fred Watson and my good self. What's my name again? Andrew Dunkley.
You're not.
I had to think about it.
Are you really good?
No, not good at all.
3, 2, 1.
Space Nuts.
Now, Fred, I'm very excited. Very, very excited. We have 902 YouTube subscribers.
Whoa.
902 people with too much spare time, which is fantastic. We're wanting to get to 1,000 for reasons unbeknownst to me, but Hugh, our producer, tells me, got to get to 1,000. Why, Hugh? Because, which is a great answer to every question ever asked. But yeah, 902 subscribers to our YouTube channel, where you can listen to every single episode of Space Nuts.
Again and again.
Over and over again. Just hit play all and just let her rip. But yeah, we want to get to 1,000. There's no prize for being the 1,000th because we've got no way of figuring out who that might be. Unless, of course, you want to tell us that you're the 1,000th. We might chuck in a T-shirt or something, but then we might get 1,000 people claiming that they were the 1,000th. So I don't know how we would do that. But anyway, if you would like to subscribe to Space Nuts on YouTube, it is youtube.com/CE for Charlie /Space Nuts, and subscribe and get out. We're going hammer and tongs. The numbers have really spiked in the last couple of weeks, which is fantastic. So thank you. Now, Fred, we've got some questions. We've got a couple of questions that are similar but different. And we're going to start with Andrew Dobbins, who refers to himself as Zombie Dob. I need an explanation, Andrew. I need to know why you are called Zombie Dob.
Same reason as you're called Zombie Dob.
I can't live without. No, I got called other things. One of my pet hates at school was being called Dumbly. Really hated that.
Yeah.
Really hated it. Anyway,
yeah.
Please tell me why you're called Zombie Dob, Andrew. Andrew says, consider the event horizon. A speeding rogue black hole grazes the event horizon of a stationary black hole. What would happen? Would part of the black hole break off and get sucked in, causing a large gravitational wave? Would it be too late and they would both merge, or would they both continue on their merry way with neither losing any mass, or something else? Thanks, gents, and keep having fun while keeping us all informed. Well, we didn't know we were doing the second part, but anyway, what do you think? Two black holes, a rogue one sort of grazing one that's minding its own business, watching pretty girls near Venus. I don't know. Could all of those things possibly happen under different circumstances?
Yes, that's the key. Different circumstances, because it all depends on the velocity, how fast the thing's going. If it's going fast enough, it is possible that they would continue on their merry way with neither losing any mass, because the bottom line here is that the event horizons, of course, the event horizon is that region around a black hole that defines the point of no return. It's where no light can escape from, and we're most of us familiar with the event horizon. But the event horizon is an imaginary surface. So you could, if the velocity was high enough, your one black hole could zoom past the other. Their event horizons, in a sense, could merge, but without the black holes themselves directly interacting. They just keep going on their merry way. There is no intermediate scenario, though, because if the speed is slow enough, then basically the two will going to orbit around each other and eventually merge, as we've seen with the gravitational wave detections. So it's one thing or the other. It's the two merging together, or nothing happening. It speeds by, and that depends, as I said, it depends on the velocity. So the first, the first choice that we've got in Andrew's multi-choice answer here: would part of the black hole break off and get sucked in, causing a large gravitational wave? The answer is no, because black holes are kind of, once you've got a black hole, you've got a black hole, and if another one comes closely enough, slowly enough, then the two will merge together to become a bigger black hole. So it's those are the two scenarios that you would wind up with.
Okay, so breaking off and no, missing each other completely, yes.
Yep, or both merging, yes.
Both merging. So there's no in between, is what you're saying.
That's right. Yes. Yeah.
Okay. So, but he said, could one lose mass somewhere along the way? Yeah,
that would be essentially part of the black hole breaking off.
No. So that's a no.
So it's a no. That's right.
Okay. So no to one question, no to two questions. What about the or something else?
Yes. So the basically, if you've got a binary answer, which is what you've got, it's either they either merge or they don't do anything. Well, there isn't anything else.
There you go. I just wanted to be clear. We're covering this from all potential angles.
That's good.
Yes. Okay. There you go, Andrew. They'll either just pass each other by or they'll get stuck together forever. Yeah. Simple as that. There is no in between. Thanks for your question, Zombie Dob. I've got to know. Let's move on to our next one, which is also about a couple of black holes. And this is from Ben in California. Now, Ben's being a bit cheeky with you, Fred. He reckons he's got you stumped. So let's see. Fred and Andrew. Now, just Fred. I don't want to consider this. Please consider the following scenario. Two black holes of equal mass are spinning around each other. I might just be the grammar Nazi here, Ben, and say each other is two words. As they spiral down...
That could be a typo, though. You could be a typo Nazi.
As they spiral down towards one another, is there a neutral plane in the space-time between them? In other words, do they counteract each other's gravitational influence? Considering a probe or photon of light placed between them, would you be able to glean any information? Maybe peel back the mysterious veil. Cheers and keep up the great content. Ben from California. Okay, my question, I think it's a real stumper. So, Fred, what do you reckon?
So, it's a really good question, actually, because the idea of a neutral plane, or it's really a neutral point between two gravitating objects, something we've already mentioned in this episode of Space Nuts in connection with the SOHO spacecraft, which orbits a point of null gravity between the Earth and the Sun. So likewise with the... It's okay, we'll keep going.
Yes,
right.
We will, yes. Oh, dear.
Likewise.
Let me just say, for the benefit of the audience, that's not the first interruption we've had during this recording.
We're going to keep going against the odds before this black hole gets us. I'm sorry, I should have had my phone on silent. I forgot to do that.
Oh, that's okay. The last interruption was Skype decided it didn't like us anymore and cut us off.
That's right. It did. Made its point very clear.
Very clear.
Okay. So two gravitating objects, you're going to have a point between them where their gravity cancels out. And the same will be true with black holes. It's not just with planets and suns. It's true with black holes. So that is, that's a good observation for Ben to make. My understanding, however, is that in the situation where you've got two black holes spiraling down towards each other, which we know exists because we've observed them now several times with the gravitational wave observatories. So that means that the two black holes have this neutral point between them. But as I understand it, they are by then sharing a common event horizon. Oh. So that neutral point is also within the event horizon. And so there's really not anything that you could glean by, if you had a spacecraft in there, it would be spaghettified just like everything else in that region. So I don't think there will be any peeling back of mysterious veils, but it is a very, very nice thought. And that neutral plane or neutral point, the null point, would be a really interesting place in the scenario. I'm sure a lot of people have looked at the physics of this, but effectively you're already gone by the time you're within that region.
Yeah, it's one of those objects in the universe where you probably go, "Oh, I know the answer," and no one would ever find out. It happened in The Hitchhiker's Guide to the Galaxy. The girl who suddenly realised the answer to life, the universe, and everything, and then the planet blew up.
Yes, that's very sad. Yeah.
But that's the truth of it, though, isn't it?
Yeah, indeed, that's right. So actually our best tools for looking at black holes at the moment are these gravitational wave observatories, and that's going to get better as more of these detectors come on stream. We'll find more and more nuances about the way black holes do combine, about the way they do spin down. There's something called the ring down, which is a phenomenon that happens right at the end of that collision, and it's when the black holes have now merged. There is a very rapid loss of energy. The whole thing just disappears off the radar in terms of gravitational waves because they're no longer accelerating. So interesting stuff, and we will learn more, but not by sitting in between two merging black holes. It would be a dangerous place to be.
I really want to try that.
Yeah.
Okay, it's like getting between your wife and her mother, really. It's same effect.
I'm not going there, Andrew, so your listeners know that.
Oh, dear. All right. Thank you, Ben, for the question. Insightful, interesting, and way off the mark. No kidding. We do appreciate the question, though. It prompts a question for me, Fred. Why do people, more so than anything else, want to ask questions about black holes? Is it because we're just so mystified by them? Is that what it comes down to?
I think it's about the fact that most people realize that our knowledge of physics basically breaks down when you're sitting on a black hole. Infinite density means nothing in conventional physics. And so the interest is really shared by astrophysicists themselves, because black holes are the most extreme examples of gravity that we know. Therefore, it's a really great place to test the best theory of gravity we have, which is general relativity, to look for holes in it and maybe find out about new phenomena in the universe. So it's good that that interest in black holes is well placed.
Yes, indeed. I know for a fact that sitting on a black hole is where physics breaks down, but the doctor told me I should be eating more fibre. So there you go.
Yeah, I'm not going there either.
Dear. All right. I think we'll call it quits for another.
That might be the end of the show,
week.
Folks.
Yeah, it could be the end of the series. Who knows? But before we go, I've got to tell you that thank you to whoever bought 2 T-shirts. That's awesome. If you would like to look into the Space Nuts shop, you go to bitez.com, bitez.com/Space Nuts, and you'll find T-shirts. Now, I have checked with Hugh, and he assures me the polo shirt is not far away. So if you're someone like my good self, I've said it again, who prefers polo shirts, the Space Nuts polo shirt is coming soon. You can call it the Space Nuts tennis shirt or the Space Nuts golf shirt if you so desire, whatever makes it feel better for you. But we'll let you know when they're available. They're not far away. T-shirts are there. So are books. Fred's brand new one, Cosmic Chronicles, known in the United States as
Exploding Stars and Invisible Planets.
Indeed. So if you want to download that one on your e-reader or get the tactile version, you can do that via the Space Nuts shop. Fred, thanks as always. It's been great fun.
It's been, I guess, fun is as good a word as any to describe.
Notwithstanding the bawdy humour.
No, it's all right. No, it's always fun, Andrew, and I look forward to talking to you again very, very soon.
I look forward to it as well. Professor Fred Watson, astronomer at large, and thank you for listening. Thank you for staying in touch. Don't forget to talk to each other on the Space Nuts podcast group on Facebook. And don't forget to check out Patreon. If you're a patron, thank you for your support, but also some more bonus material coming your way real soon. We'll catch you next week on another edition of Space Nuts.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Available at Apple Podcasts, Google Podcasts, Spotify, iHeartRadio, or your favorite podcast player. You can also stream on demand at Bytes.com.
This has been another quality podcast production from Bytes.com.